I'm Alex Soroyan, CEO and co-founder of Netris. In this section, I'll show a small demo of some of these things that I just explained. So this is Netris controller. It is blank. This is basically day zero situation. So we can see that the inventory is blank, IPAM, topology, nothing in there. Now the first step is to, initialize the controller, and of course it is possible to initialize manually by defining your switches, your IPs. But we're gonna use more simplified method. We'll use one of our Terraform modules that are, designed for particular use case. 1 second. So on left terminal, you see this is Netris controller CLI. So I'm on that machine, and there's this Terraform folder. Now this Terraform module, this is not something that customers need to write themselves. We ship this with the product. It is open. It is written in HCL language. Customers are welcome to make all kinds of changes. We will be more than happy to help them with that. Now, but in most cases, there's no need to make changes, because what you need to do is primarily to edit this file, variables file, which is, you can think about this like a questionnaire, where it's asking some of the questions that like professional services would ask, like, how many servers are you planning to deploy in your network?
Do you have a questionnaire that populates this file?
That happens manually.
Okay.
Yeah. So this particular one is designed around NVIDIA's reference architecture for Ethernet-based clusters, Spectrum-X, what they call. And in Spectrum-X, your east-west fabric has a certain prescripted design. This module knows that design. So for backend fabric, we're only asking these questions. Basically, we just need to know how many servers are you planning to have. I have 64 in this case. Now, this part is for north-south fabric. That's because north-south fabric, the front-end fabric, it is less prescriptive. There's more freedom. Customer may want to do all kinds of modifications. So that's why we ask more questions. How many live switches do you want to have? How many spine switches? What kind of redundancy you want to have between them? Now we answer these questions. We apply this module. It's applying. So what is happening? This module is basically based on that inputs. It's generating objects in Netris controller, like IP addresses, like topology information. You'll see this in a sec. We can see that these numbers are changing, so controller is being populated, and now it's done. Now I'm going to start. So 1 second. Okay, so in this demo, we're not using physical hardware. We're using a simulation. So now that I've populated Netris controller, and I explain in a second what I've done here, I'm going to create a digital twin of the network that I've designed in the Netris. That process takes about 5 minutes. So I will start that. This digital twin in this example is using our own technology we call CloudSim. We've developed it in-house. We're using Pulumi for this. It's a basically smart script that reads all kinds of parameters from controller and creates lots of VMs in a very powerful hypervisor, basically in a set of powerful hypervisors. So this way, we were able to simulate really, really large networks, like 40,000 links networks. Like, we cannot create that in the lab. Okay, so that simulation is in the process. Now let me walk you through what we've got in the controller. So we've populated inventory, and now we've got entries for servers, HGX. These are simulated GPU servers. For servers, we have a little bit of data, their name, and basically this JSON file. This JSON file basically describes the host configuration on the server. This is for the case if customer opts for using our plugin to also automate network configuration on the server. It is optional, but it's very useful. For switches, because we do a lot more with switches, we have more information, like what operating system to install, what AS number the switch should have, IP address, management IP for the switch. Then we've populated IPAM, and this becomes kind of source of truth for IPAM. Obviously, you can have additional outside source of truth, and you can connect with APIs, but within Netris, this is your source of truth. So these IPs describe...
Which kind of source of truth you can connect? So are you able to interconnect with Git, with so many control version?
So you can manage Netris through web, REST API, and Terraform, and every source of truth has something similar. So for DevOps engineers, it's really easy to write like four lines of code that takes from there and generates.
Yeah, but let's suppose that someone is touching via interface. Is there a kind of alignment between the interface or some kind of drift detection from the source of truth to the infrastructure element that is applied?
No, not really. This is more like this source of truth. So idea here is not to replace your existing source of truth, but idea here is that Netris needs to know what are your IP addresses.
Okay.
Like we like have to know that.
Okay.
So this is where you provide. If you don't have source of truth, this is it. If you have another one, perfect. Just let us know what is it. Great question. So, and then we have this place called topology. Now, this topology is the topology that we've just created with that module. And this top part is backend network. It's kind of reversed. Backend is in the top and the front end is in the bottom. But so, and you can see that this part has like lots of links connected, like crazy number of links. This is how this AI backend networks are. Lots of network connections. This bottom part is front-end fabric or north-south fabric. So there's less switches. These 4 nodes here, these are our soft gate nodes. They are connected to leaf switches, like a router on a stick. These small boxes in the bottom, these are GPU servers. So they have 8 NICs, each NIC kind of connected to each GPU, and each NIC connected to backend fabric. So
can the user select whether they want a rail network or a regular fat tree? Or do you default to something?
Yeah, that's a great question. So there are different rail optimized designs in the world, right? So, and you need to describe your design here in this topology. So Netris knows how to configure, but I've generated this in just like in a couple of minutes using that module. Now, idea of module is that some designs are very prescriptive. Like NVIDIA Spectrum X is very prescriptive. By design, it doesn't allow you to like connect in a different way. And because of that, that's how our module works. If you're doing Spectrum X, you have to do like this way. But if you're deploying a design which is less prescriptive, your questionnaire will be bigger, but you can define whatever you want. Yeah, you can.
This is Tom. I've got a quick question. You mentioned the Spectrum X module. I know that you probably have modules for the different switch manufacturers and systems that you work with. Are those ones that Netris develops and then the only place to get them is from you and your team? Or do you take submissions from the community for supporting potentially devices with different functionalities that you incorporate in there? Is it kind of a closed system, or are you more open to other people kind of helping you figure these things out?
Yeah, great question. So technically, the code of the agent that runs on the switch it is closed code. It's not open source. But we are very open in general. So when it comes to Spectrum X, because it is prescriptive, the way we've built a lot of things is based on collaboration with NVIDIA. So there is number of specifications coming from NVIDIA. It's like hundreds of pages specs that are available to us as a partner. So this agent is doing like literally that. Now, when it is less prescriptive, when there's more freedom, we are very open-minded. We are happy to listen to our customers, and we have cases when customers said, "Hey, in my particular use case, this thing should happen in a different way, like XYZ way." We are open to make these modifications in the agent if required, but customer themselves usually cannot do. But there's other part of it. If it's kind of a question that makes sense to kind of open up to a customer for modification, we do that too. In some cases, we're saying, this is a matter of preference, not best practice. So we will give you a way to make these modifications.
That makes sense. Thank you.
Yeah, thanks. Great question. So, okay, by now, the network has converged. So what happened? The switches came alive. We installed operating system, Cumulus in this case, and installed our agent. And here we can see that monitoring started automatically. So we're not only automatically generating configuration on the switches, but we also configure monitoring. And we monitor for like typical things that engineers would love to have monitored, like is wiring consistent with the topology, like is there any miswiring? Are your fans spinning right? Are your power supplies okay? Are your this BGP sessions that we have configured on switch to switch links, are they up? Are they getting prefixes? So we monitor for things like that, and if something is wrong, we let you know. Question?
Right. Thank you. Do you look at every individual link? I see 4,732 interfaces, means about half that many links.
Yeah.
You check each one to verify that it is where it's supposed to be?
Yeah, we do that. And we've tested this on like 40,000 links.
Okay. And when it's not, do I get a picture?
Yeah, so you're getting a message saying like switch port 1 happens to be connected to switch 9, switch port X, where it is supposed to be connected. So how it should be and how it is. Okay. It's a text. I can't simulate that in a simulation because simulation always makes connections right. But yeah, but with real customers, typically when we launch a new customer, when a physical is done and we run this process, we usually discover that approximately like 15% of cables are miswired, and then they go and when it's like thousands of cables.
Right. 15%'s a lot. I mean,
I was just going to say that.
And isn't that one
You can't get good help.
hard to do on your own, right? I'm going through a declarative approach. I'm trying to push code, and I don't get any drift information back from this part. I have to go fix it, then rewrite the code, push it again, and see if anything's broken. So the approach is seems like you're solving the approach problem, right, for the customer. Yeah.
Thank you. Yeah, I know myself and most people on leadership are coming from network engineering background, and we've tried to solve this problem for our prior employers, and we were like, it's a hard problem. Like it's like entire team should focus on this one thing to solve it. Okay, we've got the fabric up and running, and let's connect to some of these GPU servers and see what's happening there. Now, here on my left window, this is my controller, and because I'm running the simulation from the controller, the way this simulation platform is designed, I can use kind of a backdoor to connect to the simulated servers. Like in production, this backdoor would not exist. And this server, this host 0 in production would not have operating system by now, right? Normally we provision network, then your compute platform provisions operating system. But here, for the sake of demo, we bring up machines with operating system so you can SSH and ping here and there. Now on this machine, we have this script we call cluster ping. It takes SU ID and the host ID as input, and it calculates IP addresses based on well-known IP address plan and executes parallel pings. So in this case, I'm pinging every rail, I'm pinging production interface, and I'm pinging IPMI interface. Host 0, pinging host 0, I'm pinging myself, obviously it works, but when I ping my neighbors, it doesn't work. Why? Because I don't have any tenants onboarded. I don't have any overlay network. What I've got so far is just fabric underlay up and running. That's it. Now let's say, a tenant comes in. Maybe that's a tenant Coke, and this is how I create, VPC or isolated cluster. So I select a template, and then I will show soon what this template is. I will explain all this, what happens underneath. But basically, for first tenant Coke, I'm selecting these 4 servers, host 0 to host 3, and that's basically the list of all machines we have. Add, and for tenant Pepsi, I'll do the same, similar, same template. That's a template for AI clusters. For VPC, I'm saying create new. I could have said use 10 VPC for Coke, but that's not the intention. So I'm saying create new. Here in this list, I don't have servers from 0 to 4 because they are busy by Coke. And I will give 4 servers to this next tenant. Now, both clusters are in provisioning. While it's in provisioning, which takes like a minute or two, I'll explain what's happening underneath. So I've just used this template called template 1. Now, what is this? See what's happening. In networking, typically, everything, this VLANs, VRFs, all network configuration is tied to switch ports. And we've seen switch ports on this topology, right? This is network engineers' world, is switch ports. Network engineers work and deal with switch ports. Now, cloud operators, they don't want switch ports. They don't want to say, for this cluster include switch port 1s and like 500 switch ports. They wanna operate in terms of servers, server 1, server 2, server 3. And we have constructs for switch ports too, not a problem. This is kind of more advanced version of that construct. Now, this is the template, which is basically template between platform engineers and network engineers. It translates server 1, server 2, server 3 into what switch ports. These templates are fully editable by customers. This is just an example one where I'm saying basically, go and find switch ports that are connected to ETH1 to ETH8 of any server in this cluster. Basically, for this cluster, I said server first for servers. Basically, the template is saying, go find which switch ports are these cables connected, because you know the topology, and go and configure all the right VRFs, VXLANs on that appropriate switchboards. The next section says, for these other ports, connect another VXLAN and then create this third VXLAN for these other ports for management. Based on that template, Netris creates kind of sub-objects inside. This is object called VNet, which is virtual network. It can be VXLAN, can be VLAN, can be InfiniBand, can be any kind of virtual network. So we create 3 of those for each. In this case, it's a VXLAN. In one case, it's L3 VXLAN. In one case, it's L2 VXLAN. Anyways, 3 for Coke and 3 for Pepsi, and you can see that they are tied to different VPCs, 41 and 42. That's what makes the isolation possible. Now, if we go back to server cluster, we'll see that both provisioned. Let's see if my host 1 can ping its neighbor. See, so it works. I can ping host 2, host 3, but the next one belongs in a different cluster. I cannot ping it. And to prove the point, I will exit this one. I'll connect to that other cluster. Let me go and find that cluster. Basically, one more. Yeah, host 4. So if I do cluster ping here, I cannot ping host 0. Obviously, that belongs to Coke, and now I'm Pepsi. But I can ping host 3. No?
4.
Yeah, sorry. Host 3 is also Coke. I can ping host 5. 6. 7. One more, right? Oh, no, one more is myself, so host 4. So basically, Pepsi is host 4, host 5, 6, and 7. So 4, 5, 6, 7. All works. Okay. So this part, this part was for isolation. Now we've got 2 tenants, Coke and Pepsi. They are isolated. One, internally, training can happen, Nickel can run, cool, backend, frontend, everything connected. But how do I connect to this cluster? The cluster works. Congratulations. I'm data scientist. How do I connect to this cluster? So let's say I'm data scientist of cluster Coke, and cluster Coke has this private IP address for basically connecting to this machine. How do I connect to it? So we'll create a construct that typical cloud calls Elastic IP. So we'll select the data center because this thing can manage multiple data centers. We need to select the VPC because IPs can overlap across different VPCs. So in this case, we select VPC Coke. This defines who can access. So in this case, entire world. And here, this is basically a pool of public IPs that network engineers of this AI cloud defined for this purpose. A pool of IPs for Elastic IP. That's defined in our IPAM. And here I will paste this the actual private IP of the server, click add. Now I need to copy the public IP. Okay, come on, copy. Okay. So I'm pinging it, and timeouts, provisioning is in process, and once provisioning was done, I can see that this IP is responding. So left-hand side is my controller. I'm using backdoor. Right-hand side, this is pure internet. I'm using Wi-Fi connected here. So this ping goes through this internet.
I was wondering why it was 30 milliseconds.
Right. As evidenced by its delay.
Yeah, actually, this simulation runs in Santa Clara. It is located in our data center is basically in this zip code. Of course, it goes to like a bunch of places before it makes to the data center.
It has to go through the field day that adds a bunch of latency as well.
Yeah. It's Wi-Fi.
Yeah.
So just to prove the point that I'm not just pinging one IP, but I can connect to this machine, I will run netcat. I will run like a basic service here, and we'll say hi from AI field infrastructure field day. And so hopefully I'll be able to connect from my laptop to that TCP port. So see, this basic chat kind of proves that I'm not just pinging an IP, but when I connect to that IP, that traffic goes into like literally that machine. That's so. Any questions about this?
Oh, 2 questions. So I did hear you correctly, where you can use the same address space in multiple domains.
Mm-hmm.
Okay, and since you've just demonstrated that you can talk on an arbitrary port, you actually have some sort of firewalling capability in it.
Yeah, you know, because the way that SoftGate node talks to the fabric, it can distinguish between different VPCs, and that way we are able to kind of extend the notion of VPC into the SoftGate itself. That allows us to achieve multiple things. One is different VPCs can have overlapping IPs, and SoftGate is not getting confused. Another important thing is scalability, because this is designed for like potentially scaling to like millions of VPCs, and we allow customers to run like multiple SoftGates, like horizontally, 8, 16, 12, any number, and scaling with that VPC awareness is a pretty challenging task, and we've tried lots of things until we found the formula. So we're kind of grouping different VPCs into like different groups, so that way we can manage the scalability.
Okay, but I'm sorry, maybe can you also do firewalling at the port level?
Yeah.
Okay.
Yeah, that's a great question. So we also have ACLs where we can do just like permit deny.
I don't want to chew up. You've answered my question, and I didn't want to chew up your very few remaining minutes.
So we also have Elastic Load Balancer, as I explained, which is again VPC aware. So that's for like this is typically used in inferencing use case when you want traffic coming from the internet to be balanced between multiple servers. Now, all this example was based on Ethernet network, backend and frontend Ethernet. I wanted to also quickly show how we do this for InfiniBand networks. So this other controller here this has half of that topology, only Ethernet. And we have UFM here. So this is not a simulation. This is connected to physical UFM, physical InfiniBand switches. We can simulate InfiniBand. And I have some pings running. See, this top part is pinging from host 0, its neighbors. On left side, this is Ethernet. This is pinging on InfiniBand. And this is host 3 pinging neighbors, Ethernet, and InfiniBand. Now, each host can ping itself, cannot ping others, because there's no tenancy, there's no server clusters. So let's create Coke here. This is different cluster. That Coke and Pepsi I've showed that was in another cluster. In this case, I'm using different template called IB template for InfiniBand. So this is one, and just to show you, in UFM, you can see here we don't have any pickies yet. Pepsi, second tenant. Again, same template. I'm picking 2 other servers, 2 and 3. Both are being provisioned. While it's provisioning, I'll show the template. So I've explained the idea of this template in previous example, and you can see that Ethernet part is the same, but here we have different part that is specific to InfiniBand. It is saying for east-west, previously east-west was Ethernet in that example, right? In previous example, east-west was all Ethernet. Here, east-west is InfiniBand. So we have different setup in this template. We're saying, hey, talk to UFM, which has identifier called UFM lab, and use PKs automatically. So basically, Netris, you figure out what PKs to use. And once it's provisioned, we can go and refresh UFM, and we can see that Netris just created 2 PKs, and Netris provisioned GUIDs because Netris learns these GUIDs automatically and keeps in its database. And if we go here, we can see that host 0 can ping host 1 on Ethernet, on InfiniBand, but cannot ping others. And same from the Pepsi perspective. Ethernet operational and InfiniBand operational. That's pretty much it. We've got a minute and a half almost.
Good job.
Question. When you just deployed the servers and you were showing the mapping in the template to ETH1 through ETH7 or ETH8, were those discovered by an agent running on the host so you can map the ETH number to the MAC address for proper connectivity?
Great question. So ETH1 to 8, these are logical numbers significant to Netris. So if you go to your server, you may type ifconfig, you may see different names.
I will.
Now, for modeling your abstraction, you need this normalized numbers, ETH1 to 8. You need this. But see, when it comes to topology, cabling, validation, and we have ETH1 to 8, and on the server you have EMP47 or whatever, right? There's a place in Netris you provide mapping in the server profile. I can show documentation for this, but you provide mapping between like EMP47, your real format, and your logical format. And Netris, based on that, Netris continues doing LLDP and seeing real interface names. And based on that, Netris will tell you, hey, logical ETH1 happens to be connected to logical ETH3. And you know on the server physically which cable to change with which one.